Okay, this is the last problem I'm going to do before you try a few conversions. We're going to try to find out the mass in pounds of a basketball that's filled with liquid mercury. Mercury happens to have a density of 13.6 grams per milliliter, and the typical basketball has a diameter about 9.51 inches. Hopefully, you'll remember that density is equal to mass over volume, and so since we have the density and we can find out the volume, will enable us to find out the mass. Now, from geometry class, perhaps you can recall that the volume of a sphere is equal to 4/3 pi r cubed. So the idea, initially anyway, is I'm going to multiply 4/3 times pi times the radius cubed to find out the volume. Now, this problem is littered with dimensional changes that we have to make. So initially, I'm going to probably find the volume in terms of cubic inches and then change eventually to milliliters. But one step at a time. Let's do the volume first. So using 4/3 pi r cubed and substituting in 9.51 for the diameter divided by 2, which would be the radius, and cubing that, I think the volume comes out to be about 450 cubic inches. At this point, I'm not going to round off. I'm going to keep all my significant figures, as many as I have. So although I'm writing down 450 here, in my calculator, I'm actually keeping the entire number. Since we're going to be doing the same mathematical operation throughout this problem, we're only going to round off once. Now, obviously, this is in terms of cubic inches, and it's probably better for me if I change the volume into milliliters. And so I'm going to use dimensional analysis setup, and I'm going to change from cubic inches to cubic centimeters to milliliters. Okay, I'm starting out with 450 cubic inches. Using the back of the book, I found out that there's 2.54 centimeters in an inch, and 1 mil equals 1 cubic centimeter. Now, hopefully you noticed that this is cubic inches, of course. And so my conversion factor, 2.54 centimeters equals an inch, is not cubic. So in order to make them cancel out, of course, what I'm going to do is cube this entire expression. Now keep in mind, when you cube everything in this expression, the numbers get cubed, but more importantly, the units also get cubed. That way cubic inches will cancel out, and then I can say that 1 cubic centimeter is equal to 1 milliliter, and cubic centimeters will also cancel out. So far, my answer in terms of milliliters for the volume of the basketball filled with mercury would be about 7,376 milliliters. Again, I'm not rounding off in my calculator. I'm actually keeping all the digits. I'm just writing this down so that you can make sure that if you try this problem, you're at the same place I am. Now, some of you at this point might remember that density is equal to mass over volume. So rearranging this, density times volume is equal to mass. You will recall that I specifically converted my volume into milliliters so that it would be compatible with the density, which is terms of grams per milliliter. So you can multiply the volume, 7376, by the density, 13.6, and that will tell you the mass of this basketball filled with mercury. And that comes out to be about 100,000. Now, if I was doing the problem, I probably wouldn't do this. I would use dimensional analysis because I'm noticing my units here in terms of grams, and I prefer, the question actually asks how much will the basketball weigh in terms of pounds. By using dimensional analysis, I would start out with my volume, 7376 milliliters, and then I would use the conversion factor, the density, 13.6 grams equals 1 milliliter. By multiplying by that fraction, you can eliminate milliliters, and now you have the mass of the mercury-filled basketball in terms of grams. If you look in the back of your book, I believe there's 454 grams in a pound. Now notice that I screwed this up intentionally, that if I tried to multiply by the conversion factor 454 grams over a pound, the units of grams will not cancel. And so I have my conversion factor backwards. Flipping my conversion factor back over, You have 454 grams on the bottom, 1 pound on the top, and by multiplying by this fraction, organized in this way, you should have your answer in terms of pounds. Multiplying this out, I have that the basketball should weigh 220.955 pounds. And if you look back to the original piece of information, I believe I gave you the density, which had 3 places of accuracy. And I believe the diameter also had 3 places of accuracy. So my answer should have 3 places of accuracy. So this basketball is going to weigh 221 pounds. That's a heavy basketball.